Have another question for you guys. I think we have some time. So this is a molecular mass question for Sam, but it's also a little mathy, so maybe you guys might have to work together. It's what is the percentage of oxygen in carbon dioxide? So CO2 is carbon dioxide, and the question is, what is the percentage of oxygen in the carbon dioxide?
So this doesn't want just like the percentage of oxygen atoms compared to total number of atoms. We need to think about the weights of the different molecules. Nate, do you mind helping me out just by writing some stuff for me?
Yeah.
So if we could jump to Nate's screen, I'll just kind of walk him through it here. So the first thing we need to do is figure out how much does a mole of CO2 gas weigh. We can figure out how much a molecule of it weighs, but we're just going to go with mole. I'm not going to get too deep into what that is, but essentially a mole is a measurement for molecules that works on a human scale. So Nate, oxygen, let's just write a note. Oxygen has a molar mass of 16 grams per mole.
Oxygen molar mass is 16 grams.
Usually slash MOL, or yeah.
Yeah, let's just use the notation.
Perfect.
Okay.
And then we've got, let's see, so carbon molar mass is 12 grams per mole.
Carbon molar mass. You said 12?
12 grams per mole. And I'm pulling this all from my knowledge of the periodic table. If you were doing this in class and didn't know the molar masses, you could look them up on the periodic table. There's a great website, ptable.com, that I strongly recommend using. So, okay, and then if we look at a CO2 molecule, there are two oxygen molecules or oxygen atoms in a CO2 molecule. So to find the weight of this molecule overall, we're just going to add 12 and then 16 and then 16 again for that second oxygen.
Okay, so we're kind of like doubling this, right?
Yes, we're just doubling. Exactly. Another way to think of it is we're doubling.
Yeah, so we're just doing 16 plus 16 plus 12.
16 plus 16 plus 12.
And we get 32, 44.
Yeah. So carbon dioxide has a molar mass of 44 grams per mole. And again, a mole is just it's a certain number of molecules. It's a really big number because if you go down to the size of a molecule, the weight of that individual molecule is so tiny that we can't really talk about it in terms of human scale. So we think about many 6.022 times 10 to the 22nd power number of molecules is a mole, and that gets us to the gram level for these things, so we can think about real weights that humans deal with. Okay, so if I had 1 mole of CO2 gas, it would be 44 grams of it. So we also need to just think about how much is just the oxygen there. So just the oxygen would just be that 16 2 times.
So this is just the oxygen.
Exactly.
So we'd have a total of 32.
Right. And that's the molar mass of oxygen gas, because in our atmosphere, oxygen gas is always in the form O2. So just a minor side note there. Yeah. So then all we really need to do, and Nate, I'll leave the rest to you here, all we really need to do is figure out what is the percentage of oxygen of the entire molecule.
So we would just do 32 out of the total of 44.
That's exactly right.
And then put this in the calculator, 32 divided by 44, and we get 0.727, and if you want to convert that into a percentage, just multiply it by 100, which is 72.7%. Does that sound about right?
Which I believe was it was a multiple choice, and I believe that was one of the answers.
Oh,
so
great.
That is exactly right, Nate. Thank you.